All right, so we've had two lectures so far. This is all about the science of where, or how to think spatially. My name is Russ Congleton, and thanks for watching the video. So right now we're going to talk about lecture number 3, which is on approaches to spatial thinking. So we've had some introduction. We kind of understand what spatial thinking is all about. We've seen something about the importance of it, and now we're going to look at different approaches or different ways that we can think about spatial thinking. Okay. So there's lots of different ways of thinking, and it takes on a whole bunch of different forms. So you can think of verbal thinking and logical thinking and metaphorical thinking, hypothetical thinking, mathematical thinking. So lots of different ways. And spatial thinking is another one of those components, right? And so any kind of thinking, any form of thinking that we do usually has some kind of representational system or symbols that goes along with it, and some kind of way of reasoning, right? And so thinking is any domain of knowledge. Multiple forms of thinking are used. Okay, so science uses verbal, hypothetical, mathematical, logical together, right? Okay, so any domain has their own groupings of thinkings that they use, right? And if you're going to write a English paper, you're probably not going to use a whole bunch of mathematical and logical components of thinking, but you are going to use, maybe metaphorical and maybe hypothetical and that kind of thing. So it's important to understand that there's different components of different domains. Spatial thinking is one of those. Okay. So again, we keep coming back to defining spatial thinking in a whole bunch of different ways. Hopefully we're taking it deeper each time so that you're getting familiar, you're identifying, you're being aware of spatial thinking, even as you're going through your everyday existence in between watching these lectures. So spatial thinking is a collection of cognitive skills that's a constructive grouping or synergy or amalgam combination of three things: concepts of space, which talk about distance, direction, location, dimension; tools of representation, so things like different views, different projections, different perspectives. That came out hopefully with you in exercise number 1. Maps, different ways of representing things. And then processes of reasoning have to do with incorporating space, which is why I call this the science of where, because it's all about location, space, right? Okay. And so spatial thinking is distinct because of this space component, this locational component, this where component. And space uses a lot of different properties: dimensionality, continuity, proximity, separation, different components here of trying to structure a problem, to find an answer, to express or communicate a solution. We're using these combinations of these three concepts. Okay? And hopefully you're thinking and that you're more aware, and you've got that kind of at the forefront of your brain as you go through the day. So we already talked about the example of cholera and Dr. Snow in London. Here's another example, more modern day one. So this was from a paper by Van Geen in 2003, using a geographic information system or a computerized mapping process instead of just mapping it on a piece of paper like Snow did. And this is for Bangladesh, and they're looking at arsenic mapping, which again would cause the same kinds of issues to some extent as the cholera epidemic did in London. And so here, if you look at the details here, they recorded the arsenic levels and the depth of the well, and when the well was drilled, using GPS, global positioning system. Everybody's familiar with that, I'm sure. So the location, right? So it's got to be spatial if we're getting into location of almost 6,000 different wells. And so if you look at the figure, So there you can see on the right there that the wells that are green are okay, and the wells that are red or brown are contaminated, have arsenic contamination in them. Okay, and so the deep wells seem to be okay. If we look at a analysis, spatial analysis of what's going on, there's a distribution in space, but there's also this distance, the depth of the well component, and the deep wells were good. The shallow wells tended to be contaminated. Well, why was that? Because PVC pipe to drill deep wells, to have a deeper well, is expensive. Okay, and so if you could get away with a shallow well, most people maybe could only afford a shallow well. The problem was that the shallow wells ended up with the arsenic contamination. Okay, so this kind of detailed computer-based geographic information system or computerized mapping system obviously uses spatial thinking as part of the analysis to see what was going on and to identify the places where the wells were contaminated, and then hopefully close those wells down so that people weren't being poisoned with arsenic. Okay, so a nice spatial thinking example. Okay, so I've talked about the term GIS or Geographic Information System. This is important in almost ubiquitous in world these days. Everybody uses it, from natural resources, earth sciences, politics, history, real estate, any kind of development. GIS is just ubiquitous. It's there everywhere, and it's there everywhere because it mirrors many of the functions and operations of spatial thinking. So GIS is what was used in that Bangladesh analysis. And so what the heck am I talking about? What's a GIS? Well, GIS is a system of computer hardware, software, and people used for entering, storing, manipulating, analyzing, and displaying geographic or spatial data. Okay? If it wasn't spatial data, it would just be an information system, and there's lots of management information systems and business information systems. But when you add that spatial component, that spatial thinking, then it becomes a geographic information system. Okay? And so what does it do? A GIS links locational information with tabular information. So here we have a map. This happens to be a land cover map of the University of New Hampshire, Durham campus. And then we have some kind of a computer system that we can store the map in, but we also have a bunch of attribute information. We have what the label of the specific place was, how many acres, what the area is, what the perimeter is, whatever attributes we want. And what the GIS does is it links. Okay, so it allows us to put all that information together. So we can start asking questions like, okay, where's the best place to build a parking lot? And well, you don't want to build a parking lot where there's an existing structure. You don't want to build a parking lot where there's on a wetland or where there's already forest, because you don't want to have to cut down the trees. You also want to have things like distances. How far would the students have to walk? Can they get to campus in a reasonable period of time? And so you put all these attributes together with specific spatial data, and you can ask those kinds of questions. So that's why everyone's using GIS at this point. How far is my house from the school? Where's the nearest hospital? All kinds of information that's spatial information that gets answered by a GIS. Okay, so we have spatial knowledge. We understand that there are concepts that are building blocks of spatial thinking. Okay, and we've mentioned some of these already. You've had some experience with some of these in your first exercise, but these are concepts that are common to everyone. We kind of understand that. And then there are also concepts, as we've talked about, that are specific to a particular discipline. But generally, things that everyone would think about are things like symmetry and isomorphism, which is like similarity or one-to-one correspondence, or reflection or orientation or rotation or function, right? All these things you had to think about when you did exercise number one, where you had to rotate the figure in your head and match it up with the other one or something like that. Okay, so we understand that there's these building blocks, these things that help us with our spatial thinking. And then as we get into specific disciplines, there are concepts that are specific to that discipline, maybe relative versus absolute difference. Certainly a big one if you're in geography or natural resources or earth science would be scale, large scale versus small scale. But I'm sure you can think of other things that are very discipline specific. If you're an archaeologist, if you're an engineer, if you're a mathematician, there's different concepts, different building blocks available there. Okay. So just again, to give you some examples, when we get into a specific domain, then we add all this specific spatial domain knowledge. Okay? And it can get quite complex and it get quite extensive. And so again, you don't want to get overwhelmed by this. If you're in a specific discipline, you already know at least some of the domain specific spatial knowledge that you need. Again, in natural resources, GIS is a big deal, scale is a big deal, okay, distances are a big deal, those kinds of things. Okay, here's an example from math. Okay, so in mathematics, there are general concepts like minima and maxima, and then there's really specific concepts like hyperbolas and parabolas and all these things, right? And you go, oh, sometimes it's a little overwhelming. But most people in the world, if you said to them, "What's the maximum? What's the minimum?" People understand that. That's a kind of a general concept. But when you start talking about parabolas, people are like, I don't know what a parabola is, or you start talking about the Pythagorean theorem or something like this. Okay, and so there are some challenges there because there's this rich, complex conceptual structure, to the for that specific discipline to explain the space for that specific discipline, it can be challenging. Okay, and so you got to be careful because if you get into trying to deal with an exhaustive list, then you can get overwhelmed. But there's places to look at where commonality rules. Okay, so you see this graph here, and there's all kinds of specific terminology for that. But, anybody would call that a curve. It is a parabola, right? If you're in math, you understand it's a parabola. But if you explained it as a curve, anybody could understand it. Okay, so there's a balance. You have to understand the general building blocks and use those as often as possible. But then as you get more and more into your specific domain, you're going to increase and grow in your list of more complex terms. So hopefully that's clear from that. Okay. So how do we think and act spatially? What are some things that you're probably already doing, but you're not really aware of it? And so awareness is the beginning of improving your spatial ability. So let's look at this. Okay, let's pretend we have a problem that we need to solve. How might you think about that problem? Well, again, depending on who you are, maybe you do a little diagram, or maybe you draw some kind of a picture or a figure or some kind of a graph. Okay, or maybe just in your head, you go, okay, are there some patterns here that I need to see? Is there some kind of regularity going on? Or is there something strange? Are there, different people look at different things. Some people look at, okay, this is what's similar in this problem. Here's what's, other people go, okay, why is this different? Okay, so look for similar patterns, look for outliers or anomalies. Maybe you make a flow chart. Some people call these like mind maps, where they write things out and they look at different issues that are going with that. Do you notice any groupings or clusters? If you understand statistics, maybe you go, okay, let me use some statistics to test for something. Is there potentially some change over time or changes in space? Um, can I come up with a crude sketch? Can I draw something besides a diagram or a graph? Can I actually picture this? Okay. It helps you in your mind to visualize what's going on. Or maybe I use a physical model. Okay. That's what maps are about, right? I can't think of the whole world and hold the world in my hand, but I can open up a map. Maybe it's a paper map, maybe it's a map on the computer or on your phone or whatever. Okay. And so all those ways are thinking spatially to try to solve that whatever that problem happens to be. And again, hopefully your awareness of spatial thinking helps you to realize, oh my goodness, I'm doing a lot of spatial thinking, but I wasn't aware of it. Okay. So there's a difference between spatial thinking and spatial skills. And it's important to understand that, right? Skills can be learned and skills can be improved. And our skills are a part of spatial thinking. Okay. And so as we improve our spatial thinking, we're improving our spatial skills. Typically, skills are supported by tools or technologies. And again, you have to be careful here because I really do believe that some of our technologies are depriving us of our spatial skills. For instance, our car with a navigation system in our car, telling us to turn left, turn right, whatever. You don't have to think about that. You just do what the computer in your car tells you. That's not necessarily a good idea. Depending on where you are in the world, you may end up down a road that isn't really a road. You may get pretty lost doing that. Okay. And so I think you have to be careful about that. But here's some examples of some tools that we use, in our disciplines, in our domains. So in mathematics, you would use that graphing calculator, right? That's what would produce that parabola. Or in geography, natural resources, earth sciences, you would use a geographic information system on a computer, as we demonstrated with the Bangladesh example. Okay. Some tools are really low tech. Some tools are really, really high tech. Okay. And what I think of is, what the computer does is allows us to take some data layers, so some spatial layers with attributes, and overlay them on top of each other. But maybe sometime in third, fourth grade, something, you had some tracing paper and you drew one layer on one piece of tracing paper and another layer of information on the second piece of tracing paper. And then you overlaid those on top of each other to kind of see where things overlapped or see where things were unique, or whatever information you got out of that. And that's a GIS. That's just the human being the GIS versus doing it in the computer. Okay. And we need to understand that there's new and typically very sophisticated and expensive tools emerging all the time that potentially can help us with our spatial thinking, but we have to be cognizant of the fact that some of those tools could actually be robbing us of our spatial thinking. So it's a trade-off there. It's a balance for sure. Okay. So what's the challenge? The challenge is we should be proficient in using low-tech tools. Drawing something with a paper and a pencil, a graph, a diagram, some kind of a sketch. Okay. Using things like protractors, compasses, any kind of tools that could help us understand things spatially. I think even maps fall into that category. Okay. And then we certainly must know about the general purpose high-tech apps that are out there for us to think about, that we can use to help us with our spatial thinking. Okay. So Excel, I think everybody knows, Microsoft Office. Excel is for graphing and for statistical analysis. PowerPoint, things like Photoshop, so Adobe Photoshop, or anything that allows us to look at pictures and images. Google Earth, I mentioned before, so hopefully you've played with Google Earth. If you've never played with Google Earth, I recommend it strongly. Get on and just download Google Earth on your phone or on your computer, and then when it says search, type in your address of your house, and it'll zoom in on the earth to your house and then zoom out a little bit so you can start looking around. You can look at what your roof looks like. You can look at what your neighbors' houses look like. You can figure out where the grocery store is from there. You can figure out where the nearest shopping mall is. You can figure out where the nearest place you could go swimming. You're starting to think spatially. And then obviously GPS and GPS, I think, is a blessing and a curse. As I said, the GPS in our car, the navigation systems in our car, I think in some ways prevent us from thinking spatially. So we need to have the skills to be able to learn any new low-tech stuff, but we also definitely want to make sure we're starting to learn, some of the high-tech applications. Okay. So this can be difficult, it can be challenging, it can require some work to do that. But it is important that we keep up with that. Okay. So what are 3 characteristics if you're going to be spatially literate? What are the things that you have to be thinking about? Okay. So 1, as you're developing your spatial literacy, you should have the habit of mind of thinking spatially. So know when, where, how, and why to think spatially. So again, some of this is happening naturally for you. Hopefully, as a result of the lectures, you're becoming aware of these things, and now it's a habit of yours. You see the benefit of not just trying to solve the problem logically, but adding that spatial component to it. Okay. So secondly, you want to practice spatial thinking in an informed way. It shouldn't be haphazard. It shouldn't be by default. It should be because of your appreciation of the things that we've been talking about in these lectures, where you have some kind of command over spatial reasoning, where you've practiced and you've developed these tools over time, both the tools and the technology, so that it's showing this deep understanding, this knowledge of spatial concepts. Okay, that's only going to come in time, and maybe there's not enough lectures. There's, this is a shorter series, but you can definitely go and get the Learning to Think Spatially book or other resources that could help you if you really get into this. Okay, and then thirdly, you want to make sure you've adopted a critical stance to spatial thinking. Okay, you want to evaluate the quality of the data. You get information, you get data, and you're going to produce something from it. You need to think critically about that. Critically doesn't mean here that everything is wrong. It means that you're evaluating the value of what's going on. Okay. And then once you're in good shape with that, you want to use that spatial data to construct, articulate, and defend a point of view. So maybe you can convince somebody about something because they've not thought about the spatial component of it. Okay. And then lastly, you want to determine the validity of an argument based on spatial information. Okay. So again, it's sort of 2 sides of a coin. 1, you're going to help use the spatial information, and 2, you're going to critically assess the spatial information. So one time you use it to help you solve a problem, and the other time you use it, sort of the other side of the coin, to use it to decide whether somebody else's argument or information is valid. Okay, so what you want to do is think about this. Am I spatially literate? Do I have these 3 characteristics? Again, you don't have to have everything perfectly nailed down at this point, but are you growing in these 3 characteristics? That would be great. Okay, so we have an exercise number 2 for you now. And again, just like I had before, there's a short video explaining the exercise, so please watch the video. There's also a PDF that provides the instructions along with the link to the exercise. And this is a really fun exercise. It's just playing the game Tetris. You've probably played this before, so this is probably no big deal. I've provided a link where you can find the game if you want to find it. If you've got Tetris already on your phone or on your computer, or you've got a favorite Tetris game, it's totally fine to play whatever one that you want. Okay, you don't have to use the link that I've provided, but if you don't have one, use the link. Okay, and then in the instructions, I've provided some guidance of how I want you to go about doing this exercise. But most importantly, I've given you some questions for you to consider after you've played. So please, again, read the instructions and do it methodically, because it'll help you better become aware of the spatial thinking that you're learning while you're doing Tetris. But most importantly, the goal is to have fun. All right, that was lecture number 3, and I'll see you again when we get to lecture number 4. In the meantime, please make sure you do exercise number 2. Thanks.